Okay, so today we're going to cover section 2, which is applying congruence and triangles. So we're not officially getting into the postulates and theorems that are going to specifically prove them congruent. So for right now, when we prove two triangles are congruent, we must show that every single piece of that triangle is congruent, all three angles and all three sides. So when you have two congruent figures, these are going to be figures that have the same size and the same shape. And all of the corresponding parts of one figure are going to be congruent to the corresponding parts of the other figure. Now, sometimes when you're given the two figures, they're not going to be sitting like this, side by side. Everything matches up nice and pretty. Sometimes they'll be flipped on their side. Sometimes it'll be upside down. So what's going to be important for you to look at is the congruency statement that's going to be given to you. And the order of the letters is going to be very important. So for example, this one's nice and color-coded. Notice the two red angles. The A is going to match with the F. So when I go to write my congruency statement, I can abbreviate triangle by drawing a picture of a triangle. And then over here, I'm going to put the triangle for the second one. And I'm going to match the letters. So A is in the first spot. So over here, I'm going to write F in the first spot here. So then for the second letter, I could go to the B. Notice the B is highlighted in blue or written in blue. So I'm going to pick the other one that's written in blue. Now, what you're going to look at are the congruency marks. Notice on the first triangle, the A had one congruency mark on angle A, and so did F. Then the B had two, which matched with the E. And then lastly, the green one, the C is going to match with D. So if your triangles don't have congruency marks in them like this did, let's say you just had two triangles, and let's say the first triangle, they wrote it A, B, C, but then let's say they flipped the other triangle upside down, and you weren't sure exactly what matched. What you can refer back to is this statement over here. This statement will tell you exactly which angles to match. So for example, notice A in red matches with F, so I could put one congruency mark here and one here. Then when you get to the B, which is in the middle, it matches with the middle here. And you could put two to show that it matches. And then lastly, the last one, the green, D, it would get 3, and it would match with the C. So you can do this by just looking at the statement. So the order that you tell the triangles are congruent is important. You couldn't say that ABC is congruent to EDF, because then the angles wouldn't match. Does that make sense?
Yeah.
So the orders need to match. The order of the letters are important. Okay, and again, they've also included the congruency marks on the sides. Notice from A to B, it has one mark, and it matches with EF. And then here, AC has 2, and it matches with FD. And then lastly, BC matches with ED. So right now, in order to prove triangles are congruent, you have to be able to match up all three angles and all three sides. Next, the third angles theorem. This one states that if two angles of one triangle are congruent to two angles of another triangle, then the third angle is also congruent, so like by default. So right now they're showing that A is congruent to D. They both have two of the congruency marks, so the two tick marks. And then B matches with E. So then you could also show that C matches or is congruent to F based on the third angles theorem. If you want to abbreviate this, you could say 3 and then draw a picture of an angles. So when you're writing this as a reason in your proof, you could write it like that as the reason. Or write out the words, third angles theorem. Either way. So again, order is important to us. Everybody good on this one? So this is a way you could come up and prove the triangles are congruent as long as you know two angles are congruent. Properties of congruent triangles. We've already seen these before. We've seen them with segments. We've seen them with the point. So here, a reflexive property of congruent triangles. So it's like the mirrored image. Triangle ABC is congruent to triangle ABC. The next one is the symmetric property of congruent triangles. Remember, the word then is like the line of symmetry. And if you were to fold it up, the DEF matches and then the ABC matches. So it's like symmetric, like a line of symmetry. And then you have the transitive, which we've been using a lot in our previous proofs for the angles and the segments. But now we're going to show it with triangles. So if triangle ABC is congruent to DEF, and if DEF is congruent to JKL, then we can go right from the beginning to the end and say that ABC is congruent to JKL. So again, same idea. It's now applied to triangles. Pretty good? Next, sometimes, always, and never, everyone's favorite. So, an acute triangle is blank congruent to an obtuse. Good, never. Okay, a polygon is blank congruent to itself. Always. A right triangle is blank congruent to another right triangle. No, not always. What if we have a right triangle and let's say it's got 45, 45, 90, and this one's got 30, 60, 90. Okay? Are these always congruent to each other? No, so sometimes. All right. Then the next one, if ABC is congruent to XYZ, then A is blank congruent to Y. What if it's an isosceles triangle? What if X and Y are the same? So this is sometimes. Okay, if ABC is congruent to XYZ, then A is blank congruent to X. Always. Because see, that's in the first spot and the first spot. So the only way the one before that could have been is if X and Y were congruent. Make sense? All right. Let's go on. Another example. Okay. We actually don't have a triangle here, but we still have congruent figures. So we have quadrilateral, and it actually looks like a trapezoid. We have trapezoid ABCD is congruent to trapezoid FGHK. Again, the matching of the letters is important. So for example, it wants me to find the value of X and the value of Y. So if you notice J or GF and AB, notice in the statement, first two letters, AB, FG, first two letters, that tells me that those two sides are going to match up and that they are congruent. So to find the value of X, I'm going to set 3X minus 6 equal to 9. And that's going to give me my value of X. I now have to add 6, and I get 3X equals 15. Divide by 3, and my value of X is 5. Now I'm going to go look for the value of Y. Notice Y is over here by this angle K. And the value of the measure of angle K is 4X plus 2Y. Notice in my statement, K is the last letter. So it's going to match with the last letter over here, which is the letter D. So the value of, or the measure of angle D is 44. So to find the value of Y, I'm going to take my 4X plus 2Y and set it equal to 44. Now notice I have two variables here. But notice again also, I already found the value of X. so I can plug it in. So 4 times 5 plus 2y equals 44. I'm going to multiply. And now I have a nice two-step equation. Subtract the 20 and then divide by 2. And my value of y equals 12. So again, the order of the letters in the statement are going to be important to us. Any questions on example 2? Okay, so for example 3, it says Maggie took a piece of fabric, and it's represented by STUV. And she cut it on the diagonal to make a scarf for her and her friend. Are the two pieces the same size and shape? So basically what we need to do here is show that these two triangles are congruent. And right now the only way we can do this is to show that every side is congruent to another side in the other triangle and every angle. Now, pretty much we almost have all of our sides labeled, but I'm going to go ahead and pull this apart so you can sort of see this. So here's the SUV, and over here, I'll draw this one, STU. And again, I have a right angle here. Okay, so now I have some congruency marks. I have SV is congruent to TU, and I also have ST is congruent to UV. Now, notice the SU, this diagonal here. It's the same letters on both, right? So really, by the reflexive property, and this is going to be a big time statement you're going to use in your proofs of triangles. You're going to be using the reflexive property. So basically, I can say SU equals SU by the reflexive property. So I'm going to show congruency marks here and put 3. So now I've shown all 3 sides are congruent. So I'm part of the way through. Now I've got to go back and show my 3 angles are congruent. Now I already can see that angle V is congruent to angle T. Everybody see that? Because they're both right angles here. I now just have to show that angle 1 is congruent to the angle 4 here, and that angle U is congruent to angle S. How can I do that? Any ideas? Okay, but before we can get there, that's good. Before we can get there, what else do we have to state?
Couldn't we say minus 30 angle square?
No, because we only have 1 proven so far. We got to come up with a reason for the other 2. And he's right about the alternate interiors, angles theorem, converse. Okay, what we're going to show here is we got to figure out how we can state that those lines are parallel in order to use that theorem. Because right now, nothing is marked on here as parallel lines. But there is something in our figure that could tell us. Good. Because there's a theorem that states in a plane, if 2 lines are perpendicular to the same line, then they are parallel to each other. So we actually have 2 pairs of parallel lines here because of the right angles. So we could say that this is parallel to this, and we could also say that this is parallel to this by that theorem, by both lines being perpendicular to the same line. So now we actually have a transversal here, and this is we're gonna use now our alternate interior angles theorem converse, or theorem. Because we've just proven them parallel, so now we're going to actually use the theorem, the alternate interior angles theorem, and show that angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3 by the alternate angles theorem. Pretty good on that? So because we have proven all or shown that all three sides are congruent and all three angles are congruent, we can say that yes, it's the same size and shape for the scarf.
You said alternate interior?
Yes, alternate interior angles. Because what we could do is we could pull it apart like this. So this ST and then the transversal SU. So SU, and then angle 1 is here, which is congruent to angle 4, and then angle 3 congruent to angle 2. And this was the V and the U and the S and the T. Make sense? Actually, this was in the corner, so the S is right here. These are in the corners. Make sense? All right, so let's go on. We're going to write a proof here. Here we go. Now, first thing I recommend you do is label your picture. If your picture does not have congruency marks in there, fill it in. Okay? Because right now we're trying to prove these two triangles are congruent. And the only way we can do that is to get congruency marks on every single side and every single angle. So the first thing we're going to do is match it all up. So SV is congruent to RV. So SV is here and RV is here. I'm going to put one mark on each. Then I'm going to show that TV is congruent to WV. And then ST, I'm going to put 3 marks, is congruent to RW. And the other piece of information they've given us is angle T is congruent to angle W. So, pretty much we've got all our sides labeled. We just have to come up with a reason for the other two. So, in our proof, let's start it out. So we have a column for statements, column for our reasons. Statement number 1 is going to be given. And I'm going to actually state all 4 things here. So I'm going to rewrite SV congruent to RV. TV is congruent to WV. And ST is congruent to RW. And angle T congruent to angle W. And all of that is the given. Yes?
Would we have to write all of that for the given?
Yes. Yes. Now, later on in the chapter, we're not going to have to go through all of this and show every single side, every single angle congruent. We're going to come up with some other postulates, and we're only going to need specific things, like 2 angles and a side, or sides, all the sides, and it'll be different postulates. But right now, we don't know any of those, so we're doing the whole thing. All right, so now I need to come up with a way to prove the other 2 angles congruent. Anybody else see? And I'll make this bigger. Can anybody find a reason to show me why these other 2 angles are congruent?
Oh, S and R.
S and R, why? Is there something I could do before that?
The 2 lines that make the angles are both congruent.
Okay. All right, what about this? Let's look at this one. How about SVT congruent to RVW? What kind of angles are those? Vertical angles, beautiful. That we're going to use our vertical angles theorem. Okay, so my next statement is going to be that angle TVS, you could have also said SVT, is congruent to angle WVR. And that reason is vertical angles theorem. Yes?
The next one would be their angles theorem, since you have the other 2.
Very nice. He's got this. Okay, so angle R is congruent to angle S by the third angles theorem. Good. Now, then our...
Pardon the interruption. Is Isabella Rafa, please report to student services. Isabella Rafa, please report to student services.
And then our last statement is what we were trying to prove, that triangle STV is congruent to RWV, and that is by definition of congruent triangles. Good. So you must show on the test, if I ask you to prove two triangles congruent, that all sides are congruent and all angles are congruent. And you can use any theorem or postulate or definition that we've learned since chapter 1 as a possible reason. So this is your theorem. This is your proof for these triangles. You're going to use reflexive a lot for the triangle congruence. You're going to use vertical angles. You're going to be pulling in your alternate interior angles theorem quite often. So all of these are going to come into play throughout this chapter. Any questions on the triangle congruence? Yes?
What's number 3?
Number 3, it was the third angles theorem.